So we're starting our new unit. Our new unit is Unit 2B on equations. Girls, it's on one-step equations is what we're starting our lesson on. So I can solve one-step linear equations with just a single variable, one variable. Remember, variables are our letters, so we typically are going to be focusing on x's, but be aware you could see more than just the x as a variable. You guys have actually seen equations for a really long time. Back in first grade, in kindergarten actually even, you guys were learning about equations, but you just didn't have a variable as a missing value. You had maybe a box was missing, and you had to fill in what the box would be in order to make that statement true. Or you might have had a contextual situation where you're like, oh, I have 5 apples, but I want to have 9 apples, so how many apples do I still need? So that is all an equation format. So when we're looking here, again, instead of the box, we would put the variable, so the variable being x. So instead of a box or a missing value as plus 2, thank you, is equal to 7, it would be x plus 2 is equal to 7. Now, we need to also have an understanding of what is inverse. So when we talk about the word inverse, who can raise their hand and tell me what is another word for the word inverse? What does inverse mean that we're actually doing? Opposite. Thank you. So when we talk about inverse, we're actually talking about opposite. So inverse operations would be opposite operations. So addition and subtraction are considered to be inverse operations of each other, meaning that if I started with a value, so like if I start with the value 12, and I say, hey, I'm going to do 12 plus 3, but then I'm going to go ahead and subtract 3, it's as if I never did anything. I'd still just get the 12. It's like these plus 3s and these minus 3s didn't even exist. They cancel each other out, and you're left with what you had started with to begin. Same thing for multiplication and division. With multiplication and division, they are also considered to be inverse operations of each other. They will undo each other. So if we started off again with 12, and we said, hey, we're going to go ahead and multiply by 3, and then we're going to divide by 3, it's as if we never did anything to begin with. We would just have 12 left over again. So that multiplying by 3 and then dividing by 3, they cancel each other out. Okay, so one of the things that you always want to make sure that you are asking yourself, there are 2 questions that you should always ask yourself when you are solving equations. Question number 1 that you should always be asking yourself is, what do I see? Meaning, what operation do I currently see occurring right now? What do I see? Oh, I meant to put that down here at the bottom. My bad. What do I see as the operation? Do I see addition? Do I see subtraction? Do I see multiplication? Do I see division? I want to note what operations I'm physically seeing in the problem. So then when I ask the next question, what is the inverse? It makes it that much simpler to know what inverse operations I'm going to do in order to isolate our variable. Okay, what do I see? What is the inverse of what I see? Okay, so taking a look at problem number 1, what operation do we see occurring here? Multiplication. So I'm going to write that down, that I see that I am multiplying. Right? I'm multiplying, and not only what am I multiplying, but I'm multiplying by 5. That's what I see right now. What am I doing with the x? Currently, I see multiplication by a 5. Okay, so now I need to identify the inverse. What is the inverse of multiplying by 5? What's the inverse, guys? Dividing. Our inverse of multiplication is going to be to divide. So instead of multiplying by 5, then I'm going to do division. So my inverse is going to be to divide by 5. So when I do the inverse operation, you have to do it to both sides. So I'm dividing 5x divided by 5. I'm also going to do 30 divided by 5. Now, when I do 5x divided by 5, those 5's are going to go ahead and cancel out, and we're left with x all by itself. When I do 30 divided by 5, I'm going to be left with what? What's 30 divided by 5? 6. You guys got to wake up. Okay, let's take a look at problem number 2. We have x minus 8 is equal to negative 15. First question to ask, what do I see? What operation am I doing to the x? What am I subtracting? 8. So I see that I am subtracting 8. I see subtraction of an 8. So what is going to be the inverse of subtracting 8? Adding 8. Okay, so my inverse in this case is to add 8. So I'm going to add 8 on both sides. Now remember, you add it to like terms. I can't do x plus the 8, but I can do this negative 8 plus the 8, and those are going to go ahead and get canceled out, where x is now isolated. Then I'm going to do negative 15 plus my 8, and that's going to come out to a negative 7. All right, what I want you guys to go ahead and do is you're going to finish up the rest of these problems, number 3 and number 4, and then you're going to flip it on over to the back and do problems 5 through 10. Identify what you see, identify the inverse, and then work it out. So I want you to say, I see multiplication by 5, or I see subtraction of 8, or I see, whatever it is that you're seeing, and then what is the inverse of that? You're going to write that off in the columns, and then you're going to solve. All right, who can tell me, and we're going to do pride points, so make sure you raise your hand. We'll do pride points, but who can tell me what answer they got for problem number 3? Problem number 3, x is going to be equal to what, Brittany? 2. Okay, x is going to be equal to 2. What about for problem number 4? Mackenzie? 5, good. So here is our solutions. For problem number 3, we've got our operation here is division, so our inverse is to multiply both sides by 4. When we do 1/2 times 4, we get 2. For problem number 4, I see that there's subtraction of 8, so the inverse is going to be to add 8. So when I do negative 3 plus the 8, that gives me a positive 5. Okay, and then problem number 5. Who can tell me what they got for problem number 5? Come on, guys. It's not hard. Jadlyn? 1.7, very good. All right, what about for problem number 6? What did you get for number 6, Fahim? 12, very good. And then for problem number 7, what did you get, Grace? 22, correct. What about for problem number 8? Who got number 8? Somebody who hasn't answered yet? Do you guys need another couple minutes or another minute? Okay, here, I'll pause it for one more time. Okay, who can tell me what they got for problem number 8? Nabhan? Huh? Negative 11, good. Okay, and then what about for problem number 9? Who can tell me what they got for question 9? All right, Mackenzie, go for a second one. Ooh, not 5. For problem 9? Anybody get something different? Madison? Say it louder. No, you're going to get a whole number. Okay, I think we'll come back to problem number 9. What about problem 10? Who can tell me what they got for problem 10? Anybody who hasn't answered yet? Come on, guys, you get a pride point. All right, go ahead, Grace. Not 6. Mackenzie. 10. Okay. Let's go over these. Okay, so for problem number 5, again, we see that there is addition, so we're going to use subtraction. We're going to subtract 7.2 on both sides and get x is equal to 1.7. For number 6, I see that this is multiplication. This is 3/4 times x is equal to 9. So instead of multiplying by 3/4, we're going to divide by 3/4. So 9 divided by 3/4 comes out to 12. Problem number 7, I see that this was division, right? This is r divided by -2. So in the inverse means we're going to multiply by -2. So multiplying both sides by -2, we get r is equal to 22. For number 8, I see that this is a subtraction of -3. So the inverse is to add a -3. You would add -3 to both sides. -8 plus -3 is -11. For problem 9, again, I see that this is 4/9 times x. This is multiplication of 4/9. So that means we're going to divide both sides by 4/9, and we would get x is equal to 45. 20 divided by 4/9 is going to come out to 45. Okay, and then last problem, I see that this is x divided by -4. So my inverse is to multiply by -4. -2.5 times -4 gives me a positive 10. Okay, so you need to make sure you have an understanding of what your inverse operations are and performing those inverse operations to the other side. All right, we're going to go ahead and stop. You're going to get logged into your computers. You have a Nearpod.